My name is Dr. Colleen Wilson-Hodge. I'm at NASA Marshall Space Flight Center in Huntsville, Alabama. I do several things at NASA. I'm currently the principal investigator of the Fermi Gamma Ray Burst Monitor. So the Fermi Gamma Ray Burst Monitor is in flight. It's an experiment that's working right now, looking for gamma ray bursts, which are big explosions out in the universe. This instrument is watching what's happening, it's watching the sky, and it's my job to make sure that our science data are flowing and to make decisions that involve science and keeping everything going. We've been in flight since 2008, so this is an extended mission. The other parts of my job is I'm involved in several new missions that are in development. So the way that this works at NASA or at other institutions like universities is you write a proposal proposing what you want to do. That proposal gets reviewed. So currently I'm working on a mission called LEAP, the Large Area Gamma Ray Burst Polarimeter, to go on the International Space Station. This one, we got through the first step of the proposals, and we're currently working in the second round, which if we get through this round successfully, we get to fly. So it's a very exciting step to be in. And then there's a couple other missions that I'm involved in that we're at the beginning of proposing. Gamma ray bursts are the biggest explosions in the universe. They come from either two neutron stars merging, and neutron stars are at the end of a star's evolution, so they're the densest matter in the universe. And when they merge, they produce something called a short gamma ray burst. In 2017, we saw something very exciting with one of these events. Not only did we see gamma rays, but at about the same time, we also saw gravitational waves. Those are ripples in the space-time of the universe. Those were seen by ground-based observatories called the Laser Interferometer Gravitational Wave Observatory, or LIGO for short. And this is something that was predicted by Einstein, that when two neutron stars merge, they produce gravitational waves. This tells us things about the speed of light and the speed of gravity, that they're the same within one part of 1 quadrillion. Things from that event ruled out some other theories of gravity, not Einstein's. We learned about the densest matter in the universe, and we learned about jets. And jets are an emission of a material shooting out from when the stars merge. Gamma ray bursts are also produced by large stars exploding and forming a black hole. So all of this is telling us about the birth stages of a black hole. And the other missions I'm working on are looking at other aspects of this. Some of them are looking for additional events like the one we saw in 2017, because getting everything together so that we can see it both in gamma rays and gravitational waves is kind of hard, because we don't know where these events are going to come from in the sky. And the mission LEAP that I mentioned is looking at something else called polarization. You might have worn polarized sunglasses before. And if you put your polarized sunglasses on, you can see things like, if you're looking in water, you can see the fish in the water with your polarized sunglasses. And then if you take them off, you can't see through the water because of the reflection. Well, this is kind of the same thing. We learn things about the gamma ray burst and the magnetic fields of the gamma ray burst and exactly the details of what's happening. So this is all, it's not a save the world sort of science, but it's all very interesting. And we can only study this kind of extreme physics looking at things out in the universe. It's not something we can recreate in a lab. At one point, I wanted to be a professional hockey player. I never learned to ice skate, so it's a good thing I didn't do that. But I got interested in astronomy in about the third grade. That was when the Voyager satellites were first getting out to Jupiter and Saturn and taking pictures. And I thought back then that I wanted to study planets. So it evolved exactly what I wanted to do. In college, I wanted to do radio astronomy. And then I got a job actually working in the group I work in now, doing gamma ray burst type work as an undergraduate student. It was a program through NASA called Pathfinders. It was called the co-op program back when I did it. That kind of led me to doing what I'm doing now. In undergraduate, I got degrees in both physics and math. And then my graduate degrees, I got a master's and a PhD, both in physics. I got those at the local university here, the University of Alabama in Huntsville, while I was working for NASA. So I was doing my PhD work on the same work that I was doing at the time for NASA. My work for undergraduate, there's things I wished I would have known. Some universities offer more hands-on sorts of opportunities where you could be involved in things like balloon flight instruments or sounding rocket instruments. These are instruments that only get a little bit of data, like the balloon flights last a day. Sounding rockets get 5 minutes of data, but then you can actually get hands-on experience, which I didn't really get until later in my career. And if you can find those sorts of opportunities, if you're interested in the hardware, that's a really great thing. When I first started, I was working on a different instrument. It was called the Burst and Transient Source Experiment, and it launched about a year before I graduated undergrad, but I was working on it as this co-op student. The thing that surprised me was that the leaders of the group, I thought they knew everything at that point in my life, but there were things in the data that they were surprised by. The way the detectors on that instrument were oriented, they could figure out which direction a gamma ray burst had come from. And some of the first events that instrument saw came from the Earth. And they were like, oh no, did we get it backwards? Did we do something wrong? Did we get a sign wrong? And just hearing these experts say things like that surprised me. It turned out what happened is they had discovered something. They discovered something called terrestrial gamma flashes. And these are gamma rays coming from lightning. There's a lot of surprises out in the universe. And I guess the other surprise was that the experts didn't know everything. They had things to learn too. So in my early career on the BATSI instrument, the project I was working on was looking at something called accreting pulsars. And these are also neutron stars that I mentioned before. But what's happening is the neutron star is orbiting a regular star, and the material from the regular star falls down due to gravity onto the neutron star. And because the gravity is strong on the neutron star, it heats up and it emits X-rays. Those neutron stars have really strong magnetic fields, and that makes any emission that comes out come from the poles. So as it swings by, you see a flash of light at the rotation period of the star. There were a couple of pulsars that I discovered in the BATSI data. Every day we went through the data and looked for new signals. And most of the time there was nothing new, but a couple of times there was something new, and I was the only person that could see that. For just a little while, I was the only person that knew about it. So that was really exciting. The other really exciting thing in my career was very different. In 2013, I got to work on a project that was called HEROES, high energy replicated optics to explore the sun. This was a balloon flight telescope, a hard X-ray telescope, and we were going to look at the Crab Nebula and the sun with this telescope in our one-day flight. I got to do everything hands-on in this case. I tested the detectors, made sure they were working so we could command while it was in flight, and I would make sure the voltages were right, look at the data coming in. We did all of the calibrations, shining X-ray sources on the telescope and getting it all aligned right. So it was a very different experience than other things I've done in my career, but it was a lot of fun. So the one event we saw in 2017, it probably opened more questions than it answered, because it was the closest gamma ray burst that we've seen, but it was also the faintest. It was a lot fainter than you would expect it to be that close. And we think it's because usually for gamma ray bursts, you're looking straight down the jet that's coming out. And for this one, we were kind of off to the edge. If you think of like a flashlight beam, how it's bright in the middle and fades towards the edges, we were thinking we were looking kind of towards the edge. But there's several different models that could explain that. So we're not completely sure. So we need more events to really understand that. It also took about a second and a half between when the gravitational waves arrived and the gamma rays were seen. So exactly what causes that delay? Is that the gamma rays punching out? Is that the black hole collapse time? There's lots of things we don't know, so we can learn more. And then I guess the other things in the field that are a big deal is back in 2014, when LIGO saw the first merger of two black holes producing gravitational waves. We saw this tiny blip in the GBM data in the gamma rays, but we could really only identify which half of the sky it was in. So we don't know if it was related or not. Most of the models that we have don't predict any matter that would produce gamma rays or other electromagnetic waves, but that would be really cool if there's more of them. And there's also the possibility of a black hole and a neutron star merging. Would those produce gamma rays? LIGO has seen a couple of those events, but we didn't see any gamma rays. We don't know if they were pointed towards us or not. So there's a lot of new things to explore with those kinds of events. My days are a lot of meetings because I work on a lot of projects, but hopefully I get to carve out a little bit of time to look at data and analyze it and sit there at my computer and try to do things. Before COVID, my job involved quite a bit of travel where I would go to conferences. I would go up to the NASA Center, Goddard Space Flight Center in Maryland, and other places to visit collaborators and to work together. So it was kind of a variety of things, variety of days. Soft skills are extremely important. I think any job, people are probably the hardest part. I've spent a lot of time taking leadership classes and classes for how to have difficult conversations with people. A lot of people undervalue the soft skills in technical fields, but when you're working with a team of people, they are crucial. In terms of technical skills, a science background is important. Programming skills currently it's Python, but whatever the language of the time is. Math is something I use regularly. I've even used trigonometry to look at how long a satellite could contact a ground station. But yeah, math, science, and programming skills, I would say. And then, of course, the people skills. There is a NASA internship program. That's something I would certainly encourage. I would say explore colleges, talk to people, find out what colleges offer things along the lines that you think you're interested in, and be willing to change exactly the specialty. Like I said before, I was interested in planetary astronomy and then radio astronomy, and then I ended up in gamma rays. There's a lot of variety. When you're a student coming up, don't be afraid to ask questions. When students have asked me questions, I realize I didn't explain something well enough. It's not their fault, it's mine. I left out something that they didn't know, or I assumed they knew something they didn't. And sometimes a student asking me a question makes me realize something important I hadn't thought of. So don't be afraid to ask questions, and don't think everybody knows more than you, because they might not. My kids have enjoyed the various NOVA programs. If you're interested in gravitational waves, the LIGO website has a huge number of resources available. The NASA sites also do as well. Most of the sites have information for students available, so you can learn about different missions and the different science that they do.